Statistically speaking, you're impossible. The odds of you existing right now, reading this, are so astronomically small that mathematicians have trouble even writing the number. We're talking about odds worse than winning every lottery on Earth simultaneously for 1,000 years straight. And yet, here you are. But here's what's going to blow your mind. It's not just you that's impossible. The entire universe is balanced on a knife's edge so impossibly thin that if gravity were slightly different, stars would never have formed. Life would be impossible. Reality itself would collapse. So how did you beat odds that make winning the lottery look like a sure thing? Let's start with the universe itself, because before you could exist, the cosmos had to get everything exactly right. According to Sir Martin Rees, one of the world's most distinguished astronomers and the Astronomer Royal of the United Kingdom, our entire reality hangs on a specific mathematical balance. He calculated something that should terrify and amaze you in equal measure. If the force of gravity in the early universe had been stronger by just 1 in 10 to the 40th power, stars would burn out too quickly for life to evolve. Let me repeat that number. 1 in 10 to the 40th power. That's a 1 followed by 40 zeros. That's the precision we're talking about here. Think about that. Stars, the massive nuclear furnaces that create every element in your body, that provide the energy for life itself, that light up the night sky. They exist because gravity has exactly the right strength. Not close to the right strength, exactly the right strength. If gravity were stronger by just that impossibly tiny fraction, stars would be miniaturized. They'd burn through their fuel 1,000,000 times faster than they do now. Instead of our sun living for 10 billion years, it would exhaust itself in about 10,000 years. There wouldn't be enough time for planets to cool, for oceans to form, for the first single-celled organisms to evolve. But if gravity were weaker by just 1 in 10 to the 40th power, stars and planets would never even form. The universe would be an endless void of cold hydrogen gas drifting through darkness. No fusion, no heat, no light, no chemistry beyond the simplest elements. Just nothing. We exist on that razor's edge, that impossibly thin line between too much and not enough. And here's what makes this even more insane. We assume our sun is normal, but it isn't. 75% of all stars in the universe are red dwarfs. Violent, unstable, and blasting their planets with sterilizing radiation. These stars are death traps for life. To live, we needed a G-type star. Yellow, metal-rich, and calm. Only 7% of stars in the entire galaxy are G-type stars like our sun. 7%. We didn't just need any star. We needed to be born around one of the rarest, most stable types of stars in existence. But even that wasn't enough. Most sun-like stars are born in pairs. They're binary systems, with 2 stars orbiting each other. If the sun had a twin, the gravity would have flung Earth out of the solar system and into the freezing dark. No stable orbit means no stable climate. No stable climate means no life. We needed a single star, and we got one. But here's where it gets even more ridiculous. Data shows that most stars like the sun erupt in superflares roughly every 100 years. Explosions strong enough to strip away a planet's atmosphere. Our sun has been silent and calm for millennia. For thousands upon thousands of years, while life was struggling to gain a foothold on Earth, while single-celled organisms were slowly evolving into complex life, our sun just didn't explode. Why? Nobody knows for certain, but if it had behaved like most stars of its type, you wouldn't be here. None of us would. The universe had to roll a perfect combination just to give us the right star. But that was just the beginning. In simulations of the universe, 91% of Earth-like planets fail. They get destroyed before complex life can evolve. Why? Asteroids. Earth should be pummeled by asteroids constantly. Extinction-level impacts should happen every few million years, wiping the slate clean before intelligence can develop. But Jupiter's massive gravity pulls asteroids away from us. It acts as a cosmic vacuum cleaner, intercepting threats before they can reach the inner solar system. Without Jupiter, life would never evolve past a single cell before being wiped out by extinction-level asteroids, over and over again. An endless cycle of destruction with no time for complexity to develop. We needed a gas giant in exactly the right orbit, with exactly the right mass, positioned exactly where it needed to be to protect us. And somehow, against all odds, we got it. Billions of years ago, a planet the size of Mars hit Earth. If it had hit head-on, Earth would have been vaporized. Game over before the game even started. Instead, it hit at exactly the right speed and exactly the right angle to carve out a piece that became the moon. Without the moon, Earth would spin out of control and wobble on its axis. Our planet is steady only because our moon is heavy enough to lock Earth's axis in place. Without the moon, climate on Earth would be a chaotic blender that cannot sustain life. Seasons would be random. Temperature swings would be catastrophic. The poles would shift unpredictably. The moon wasn't just a lucky accident. It was a precisely calibrated collision that happened at exactly the right angle, at exactly the right speed, with exactly the right mass to create the one thing that would stabilize our planet for billions of years. What are the odds of that? The asteroid that killed the dinosaurs hit the Yucatan Peninsula. If it had arrived just a few minutes late, Earth would have rotated, and the asteroid would have landed in the deep Atlantic. The dust cloud would have been smaller. The dinosaurs likely would have survived, and mammals like us would never have risen to dominance. Think about that. A few minutes. If the dinosaurs had survived that impact, they would have continued to rule the planet. Mammals would have remained small, insignificant creatures hiding in the shadows. You exist because a massive asteroid hit the exact right spot on a rotating planet at the exact right moment in geological time. Too early, and life wouldn't have been complex enough. Too late, and mammals might never have gotten their chance. The margin for error was measured in minutes across 65 million years of history. But all of this, every single one of these cosmic coincidences, rests on an even deeper foundation. The fundamental forces of the universe had to be calibrated with impossible precision. The strong nuclear force, the force that holds atomic nuclei together, operates within a terrifying margin of error. If it were just 2% stronger, all the hydrogen in the universe would have been converted to helium during the Big Bang. No hydrogen means no water. No hydrogen means stars burn out almost immediately. The universe would be lifeless. But if the strong force were 2% weaker, deuterium wouldn't be stable. And without deuterium, the fusion chain that creates heavier elements inside stars gets completely blocked. No carbon, no oxygen, no elements needed for life. 2%. That's the window between a universe with nothing but hydrogen and a universe with no hydrogen at all. The weak nuclear force, which governs radioactive decay, had to be precisely calibrated to create the right ratio of hydrogen to helium in the early universe. Too strong or too weak, and stellar formation breaks down completely. Then there's the most terrifying fine-tuning problem of all, the cosmological constant. The cosmological constant represents the energy density of empty space itself. Quantum mechanics predicts it should be enormous, but when we measure it, we find it smaller than predicted by a factor of 10 to the power of 120. That's not a typo. 10 to the power of 120. If the cosmological constant were even 50 orders of magnitude larger than its current value, the universe would have exploded apart so violently that no structures could ever form. No galaxies, no stars, no planets, just particles flying apart into an ever-expanding void. Physicist Paul Davies calculated that to get the value we observe, the cosmological constant and vacuum energy must cancel each other out with precision better than 1 part in 10 to the 50th power. Imagine trying to measure the width of North America and being accurate to within the width of a single atom. That's the kind of precision we're talking about for just one of the physical constants. And there are dozens of these constants, all sitting at exactly the right values. Okay, so the universe threaded an impossible needle. Multiple impossible needles, in fact, all at the same time. The fundamental forces balanced perfectly. We got the right type of star. That star was single and unusually calm. Jupiter formed in exactly the right place. The moon was created by a perfectly angled collision. The dinosaur-killing asteroid hit the exact right spot at the exact right time. After all of that, we still need to get you here specifically. For you to exist, Every ancestor of yours had to survive, reproduce, and keep that chain unbroken across 150,000 generations. An improbability of 1 in 10 to the 45,000th power. But it's not just that they survived. The exact right sperm had to meet the exact right egg in every single one of those generations. The odds of your parents meeting? Roughly 1 in 20,000. The odds that the exact sperm that created you met the exact egg? 1 in 400 quadrillion. When Dr. Ali Benazir calculated the full probability chain, factoring in 150,000 generations of survival and 400 quadrillion genetic possibilities per generation, he arrived at 1 in 10 to the power of 2,640,000. Your existence is a probability of 1 in 10 to the 2,640,000th power. For comparison, the number of atoms in the known universe is 10 to the 80th power. If you imagine the entire universe to be packed solid with sand, finding you isn't like finding one specific grain in that heap. It's like finding one specific grain and then successfully doing it again, billions of times in a row. The universe had to get gravity right to 1 part in 10 to the 40th. Then you needed to be born around one of the 7% of stars that are G-type. That star had to be single. It had to be unusually calm. Jupiter had to form as your planetary shield. The moon had to be created by a perfectly angled collision. The dinosaurs had to die at exactly the right moment. 150,000 generations of ancestors had to survive everything. And then one specific sperm out of trillions had to win the race. All of that, in sequence, without a single failure. Albert Einstein said there are only 2 ways to live. You can live as though nothing is a miracle, or you can live as though everything is a miracle. The next time someone tells you that you're 1 in a million, you can tell them they're not even close. You're 1 in 10 to the power of 2,640,000. You're statistically impossible, and yet you're here. So what are you going to do with your impossible existence? Because whatever it is, you've already beaten the most ridiculous odds in the history of the universe just to have the chance. You shouldn't be here, but you are. And that, when you really think about it, is absolutely extraordinary. Drop a comment below and tell me what you've chosen to do with your statistically impossible life.